The Lockheed Martin F-22 Raptor is an American single-seat, twin-engine, all-weather stealth tactical fighter aircraft developed for the United States Air Force. As the result of the USAF's Advanced Tactical Fighter program, the aircraft was designed as an air superiority fighter, but also has ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems and conducted final assembly, while Boeing provided the wings, aft fuselage, avionics integration, and training systems. The aircraft first flew in 1997 and was variously designated February 22nd and F-22 before it formally entered service in December 2005 as the FA. Although the USAF had originally planned to buy a total of 750 Fs, the program was cut to 187 production aircraft in 2009 due to high costs, a lack of air-to-air missions at the time of production, and the development of the more affordable and versatile F-35. The last F-22 was delivered in 2012. While it had a protracted development and initial operational difficulties, the F-22 has become a critical component of the USAF's tactical airpower. The fighter's combination of stealth, aerodynamic performance, and mission systems enabled a leap in air combat capabilities and set the benchmark for its generation. The F-22 is expected to serve into the 2030s and eventually be succeeded by the USAF's next-generation air dominance NGAD manned fighter component. In 1981, the U.S. Air Force identified a requirement for an advanced tactical fighter ADF to replace the F-15 Eagle and February 16 Fighting Falcon. Code-named Senior Sky, this air superiority fighter program was influenced by emerging worldwide threats, including new developments in Soviet air defense systems and the proliferation of the Sukhoi Su-27 flanker and Mikoyan MiG-29 Fulcrum class of fighter aircraft. It would take advantage of the new technologies in fighter design on the horizon, including composite materials, lightweight alloys, advanced flight control systems and avionics, more powerful propulsion systems, and most importantly, stealth technology. In 1983, the ADF Concept Development Team became the System Program Office SPO and managed the program at Wright-Patterson Air Force Base. The Demonstration and Validation DEMVAL Request for Proposals RFP was issued in September 1985, with requirements placing a strong emphasis on stealth and supercruise. Owing to the immense investments required to develop the technology needed to achieve performance goals, teaming between companies was encouraged. Of the 7 bidding companies, Lockheed and Northrop were selected on the 31st of October 1986. Lockheed, through its Skunk Works division, then teamed with Boeing and General Dynamics, while Northrop teamed with McDonnell Douglas, and the two contractor teams undertook a 50-month DEMVAL phase, culminating in the flight test of 2 technology demonstrator prototypes, the 22 yen and the 23 yen, respectively. Concurrently, Pratt & Whitney and General Electric were awarded contracts to develop the 119 yen and 120 yen engines respectively for the ADF engine competition. DEMVAL was focused on system engineering, technology development plans, and risk reduction over point aircraft designs. In fact, after the down select, the Lockheed team completely changed the airframe configuration in the summer of 1987 due to weight analysis during detailed design, with notable changes including the wing planform from swept trapezoidal to diamond-like delta, and a reduction in forebody planform area. Contractors made extensive use of analytical and empirical methods, including computational fluid dynamics, wind tunnel testing, and radar cross-section RCS calculations and pole testing. The Lockheed team would conduct nearly 18,000 hours of wind tunnel testing. Avionics development was marked by extensive testing and prototyping and supported by ground and flying laboratories. During DEMVAL, The SPO used the results of performance and cost trade studies conducted by contractor teams to adjust ADF requirements and delete ones that were significant weight and cost drivers while having marginal value. The short takeoff and landing stall requirement was relaxed to delete thrust reversers, saving substantial weight. As avionics was a major cost driver, side-looking radars were deleted, and the dedicated infrared search and track IRST system was downgraded from multicolor to single color and then deleted as well. Space and cooling provisions were retained to allow for the later addition of these components. The ejection seat requirement was downgraded from a fresh design to the existing McDonnell Douglas ACES II. Despite efforts by the contractor teams to rein in weight, the takeoff gross weight estimate was increased from 50,000 pounds (22,700 kilograms) to 60,000 pounds (27,200 kilograms), resulting in engine thrust requirement increasing from 30,000 pound (133 kN) to 35,000 pound (156 kN) class. Each team built two prototype air vehicles for DEMVAL, one for each of the two engine options. The 22 Yen had its maiden flight on the 29th of September 1990 and in-flight tests achieved up to Mach 1.58 in supercruise. After the DEMVAL flight test of the prototypes, on the 23rd of April 1991, Secretary of the USAF Donald Rice announced the Lockheed team and Pratt & Whitney as the winners of the ADF and engine competitions. The YF-23 design was considered stealthier and faster, while the 22 Yen, with its thrust vectoring nozzles, was more maneuverable as well as less expensive and risky. The press speculated that the Lockheed team's design was also more adaptable to the U.S. Navy's navalized advanced tactical fighter in ATF, but by fiscal year FY 1992, the Navy had abandoned ADF. As the program moved to full-scale development, or engineering and manufacturing development (EMD), the production F-22 design had notable differences from the 22 Yen, despite having a similar configuration. The wing's leading-edge sweep angle was decreased from 48 to 42, while the vertical stabilizers were shifted rearward and decreased in area by 20%. The radome shape was changed for better radar performance, and the wingtips were clipped for antennas. To improve pilot visibility and aerodynamics, the canopy was moved forward 7 inches 18 cm and the engine inlets moved rearward 14 inches 36 cm. The shapes of the fuselage, wing, and stabilator trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. The production airframe was designed with a service life of 8,000 hours. To enable early looks and troubleshooting for mission software development, a Boeing 757 was modified with F-22 mission systems to serve as the flying testbed avionics laboratory. If you like the video, thumbs up and subscribe my channel.